Okay, so this is always one of the more challenging times of day to give a speech after everyone's eaten and is nice and tired, and I have to keep everybody awake, so I'll do my best job. As Tyler mentioned, I'm a nutrient management specialist, but I essentially anything that has anything to do with soils, soils with nutrients, soil with water, soil with compaction, we're kind of looking at it. And one of the studies that Aaron will talk about here in a little bit is dealing with grazing and baling of corn stalks, and he'll talk about the dynamics of that and how that's kind of affecting things out at our rural field site. But I thought it was a really good opportunity to go in there and actually do some compaction measurements to see if we're actually, by having the cows out there grazing the corn stalks, by having the baling equipment out there baling off the corn stalks, are we affecting soil compaction in any way that might be negative? And what we're really worried about with our soil compaction becomes with water infiltration. If we compact the soil greatly, it can really affect how water moves into the soil, and it also can affect root growth if we get to a really compacted state to where the roots won't grow very well. So we wanted to see if grazing and baling these corn stalks is having any major effect. So just kind of as an introduction, management practices that produce, return, and leave more residue biomass in the soil generally have the potential to decrease bulk density. So this bulk density is one of the things of how we measure compaction. I'll talk a little bit here in a second, kind of defining what that bulk density is and how that works. Has the potential, to increase porosity. So if we increase the amount of pore space we have in the soil, we increase the potential for water to move into that soil. Increase soil aggregation. So this in effect goes with the porosity. As soils become aggregated, or as they kind of bind together and form kind of mini little dirt clods, you might call them, as those are formed, that also creates pore space in the soil, or void space in the soil, then allows for this porosity and allows water to infiltrate into the soil. And then we can also increase our soil organic matter, which also increases our mineralization capacity to provide nutrients to the plants. So by having management practices that leave as much residue as possible in the soil and management practices that do not disturb the soil as much as possible, we're really increasing the potential for the soil to provide water for the crops and provide nutrients for the crops as well. And compaction will affect all these things. We're compacting the soil and we're kind of negatively affecting these things that allow for that water to get in the soil, allow for really good root growth. So here is bulk density. This is one of the ways in which we measure the compaction of the soil. And bulk density is just defined as the dry weight of soil per unit volume of soil. So if you imagine you have a little ring, how much soil can you get into that ring? If you have a lot of it in there, then you'll have a high bulk density. If you have a little bit in there, then you'll have a lower bulk density. And the ideal soil is we really want to have about half of the space in any given volume be solids, or the mineral fraction of the soil, and about half of that space be pore space, or area, just void space, essentially, where we can move water into the soil, and we can also have gas exchange in the soil as well. So ideally we would have about half and half, and that way the soil would be a really good, not compacted so roots can't grow, and also have enough void space so water can get in there. Now the soil mineral fraction itself, the part of the soil that you can actually feel with your fingers, if you packed a ring with that solely, and there's no void space whatsoever, we would have about 2.66 grams for every cubic centimeter of volume. So that's how much just that mineral fraction itself would weigh. So ideally, if we have this 50-50 split where we have half pore space, half solids, then we would have about 1.33 grams per cubic centimeter. So that would kind of be our ideal amount of bulk density that we would have in the field. So as we get up and above this 1.33 grams, then we're starting to measure where there's more soil, less void space. And as we compact soils, we're pushing more soils into that area, getting rid of that void space and increasing that bulk density. So a higher bulk density level is going to mean a more compacted soil. Here's how crop residues can affect some of these properties. So here's a study that we did where we measured the amount of crop residue that was returned to a field. This is over a 12-year period. So over a 12-year period, up to about 60,000 pounds of corn residue was put into the system. This is for a dryland system actually in eastern Colorado. And we can see that as we increase the amount of crop residue returned to the system, we actually decrease our bulk density. So more residue placed in the system over time, less amount of bulk density. And this goes to several reasons. First of all, when these crop residues decay over time, they actually release products that kind of act as a glue and kind of bind soil together and create that aggregation I talked about, which then creates void space in the soil. And then also with an increased amount of crop residue, that's going to be introduced in the system, and that's actually going to create kind of a void space itself with having that crop residue in there instead of the mineral fraction. So over time, we can really decrease our bulk density by placing a lot of residue into the system. And then we can see how does that bulk density affect our water infiltration, because that's one of the things we're really interested in. And here we see as our bulk density increases along the bottom, so as we increase our bulk density, over here on the left axis here we have our actual infiltration of water. So as bulk density increases, we're actually decreasing the amount of water that can get into the soil. And that makes sense, right? Because if we increase bulk density, we're decreasing the amount of porosity we have in the field. Less void space for water to move into it, and therefore much more difficult for that water to infiltrate into the soil. So here's kind of a visual example of what we're looking at. On the left here, we've got a system that was in no-till for about 20 years, or excuse me, on the right is where we had no-till for about 20 years. Put a ring in the soil, pour a certain amount of water into it, measure how long it takes for that water to infiltrate. Well, on the right here, where we had a really high amount of aggregate stability, or a high amount of void space, if you will, that water really moves in at a rapid rate, about ½ an inch per minute. Okay? On the left, this is just a conventional tilled field over that same amount of time. Far fewer water-stable aggregates, less void space, and the water just doesn't infiltrate near as rapidly. Here, only about ½ of an inch per minute. So in an area where we can really increase that porosity in the soil, we're going to increase our infiltration by as much as 5 times in some cases. Here's what those same core locations, so these are those same rings. The soil was just pulled out. And here's what it looked like at the bottom. So on the conventional tillage, you can see there's no real pore spaces, as you can see, no channels for that water to move in. This is what analogous to a highly compacted soil that we have, right? On the right here, after 18 years of no-till, we see these pore spaces here. And this is due to that aggregation. As the soils kind of bind together, they create pore spaces. And these are areas where water can really infiltrate in the soil. So this would be a soil that is not as compacted.
Was there any cover crops put in there?
This wasn't cover crops. This was just a, if I remember correctly, this was a dry land field with wheat, corn, fallow. One was tilled and one wasn't. Okay, so now that we have a little bit of a background of how things become compacted, why it really affects things, how we measure that, we'll talk about what happened when we looked at how the grazing and the baling affected the actual compaction and bulk density of the soil. So this was done out at the University of Nebraska Water Resources Lab in Brule, so about 2 hours west of here or so. And these are soil compaction measurements across a check treatment where there was no grazing, no baling whatsoever, a light grazing, a heavy grazing, and Aaron will get into more of the details of the differences between the light grazing and the heavy grazing, and a baled. And this is all on the surface, 0 to 1 inches of soil. All of these compaction measurements were taken in the spring after the cows had come off the field and they'd grazed it for the majority of the winter before planting. So all this was done probably around April 1, all these measurements were collected. And this is across 3 years, 2011, 2012, and 2013. And we plan on continuing the study as well. We'll take measurements again this year. And what we found is the first year, everything kind of lined up exactly how you might expect. These letters here mean that there is a statistical difference. So there's a different letter, there's a significant difference statistically. The check treatment had the lowest amount of compaction, light grazing a little bit more, the heavy grazing and the baled treatments had the highest amount of compaction. So, if we were to hypothesize what was happening out here, this is what we'd expect to see. Then we went back in 2012, took the exact same measurements. Everything is geo-referenced with GPS. We went to the exact same location in the field, collected all the same measurements again, same time of year, just a year later. And in this case, we see the same basic trend that we saw in 2011, but now we see no statistical difference across any of the treatments. So essentially, all of these treatments, we can't say that there was any difference in them, in compaction. And then in 2013, back again, and now we see kind of even a different trend. The check and the light are still kind of lower than the heavy and the baled, and now we have some significances, but it's a little more jumbled. Okay, so again, that was from the 0 to 1 inch. Here was the compaction from 1 to 2 inch. In 2011, again, we see the check is lower than the light, heavy, and baled. Same basic trend in 2012, but again, no significant differences statistically. And then in 2013, really only the heavy treatment has any differences, and it's just different than the check and the light. So again, no consistent results as to what's happening in terms of soil compaction across grazed and baling treatments. This is from 2 inches to 3 inches. Now things start to level out a little bit in 2011, as you'd expect. As you go deeper in the soil, you expect to see less impact from the cows or from the baling equipment. 2012, we see that the check was significantly less than all of the other treatments. And then in 2013, we see that there's the same trend as in 2012, but again, no significant differences. Here's from 3 to 4 inches. Again, things are starting to level out in 2011. The bale treatment is the only one that's really significantly higher. The heavy and baled are higher than the check and the light in 2012. And then in 2013, things just kind of go all over the place, but again, there's no significant differences. Now, what this is telling us is that there's really no clear trend as to how grazing the corn stalks or baling the corn stalks affects soil compaction. We do see that it does affect soil compaction, but it changes from year to year. A lot of that's probably going to depend on how cold it was during the winter, how long a time the soil was frozen, because as that top layer is frozen, the cows probably aren't going to compact anything. And then how wet it was as well. If it's a wetter winter where we have more freezing and thawing, there's going to be more of an impact from the cows being out there. So it's not just as simple as, do the cows affect compaction? They do, but how they affect it really depends on climatic variables, how wet it is out there. Now, after stating that, the good news is that none of these values from 2011 to 2013 are cumulative. What I mean by that is if you look at the same exact location in 2011, 2012, 2013, that compaction level is not increasing over time. It's not at one value in 2011, a different value in 2012, and then a higher value in 2013. While there are compaction differences, it seems to reset, right? So after we get in there and we plant the corn, we harvest the corn, we're kind of back to a different normal to where the cows then go out and affect it. So there's no cumulative effect that we can see, at least over a 3-year time period, to where the cows are making things worse over time. They're affecting it, but not making things in any way worse. And then another point is that we're not seeing any yield effects of this. So even if we do have some compaction, it's not to the level where it's causing any problems with getting water in the soil or causing any issues with root growth. So yeah, we are affecting compaction, but not to a level to where it's causing any problems agronomically that we can find. So while there are differences across here, right now most of these differences are kind of on an academic level. Yeah, we can see things are happening, but from a practical standpoint, we don't think that they're causing any real problems in terms of growing the crops. So that's good news. Here's this study was done at Mead, so this is in eastern Nebraska. And here's looking at bulk densities across a fall grazing treatment, a spring grazing treatment, and no grazing. This was all at a 0 to 6 inches. There are 2 different sites, and each of these treatments was imposed for 20 years. And we just recently went in and looked at bulk density differences to see if after 20 years grazing the ground, can we see differences in soil compaction. Well, in our first site, we see a trend, but it's the opposite of what you might expect, right? The no grazing actually had a higher bulk density than the spring grazing or the fall grazing. And there's no significant differences here anyway statistically. So really, we can't say that there was any difference in how spring grazing, fall grazing, or no grazing affected bulk density. There appears to be no effect whatsoever by the cows in terms of soil compaction. On the second site, we did see a difference. We did see that the no grazing was significantly less than either the fall grazing or the spring grazing. But you can see these are the exact same scales on both graphs. Our second site had overall quite a bit lower bulk densities than our first site. So even though we see a difference here, it's kind of the same story as we saw at Brule. Yeah, we're seeing some differences in compaction, but they're not near the levels that are going to cause us any issues. And generally speaking, we wouldn't expect bulk densities to have an effect on root growth until about 1.6 grams per cubic centimeter, and we're nowhere near that here. On site 2, we're not even to 1.45. We're at about 1.5 on our site 1. So even after 20 years, we're not seeing any effect of grazing of the cows in terms of compaction. And even if we're getting kind of closer to this 1.6, you can see that our no grazing is up there as high as anything else for that particular site. So some considerations that we want to think about. Grazing removes much less residue than does baling, right? The cows preferentially eat leaves and husks, which is a fraction of the total residue. So while they're out there removing residue, they're not taking a large amount of it, which goes back to that, how that residue really helps us in terms of our soil properties. So we don't really think that's an issue. Baling does involve heavy equipment, and that does increase our compaction concerns. And what we've been able to conclude so far is that grazing and baling do affect soil compaction. And baling does appear to have more of an effect on that soil compaction than does grazing, or excuse me, baling has more of an effect than does grazing. But the levels of compaction bulk density that we're seeing right now do not appear to be of any great concern whatsoever. They're not to levels where we would expect to see runoff problems or root growth problems. And no soil properties appear to be negatively affected either. I can't mention that on this study here, we've also looked at how the different grazing effects might be, or treatments might be affecting nutrient cycling, so how it might be affecting whether certain nutrients become more available or less available to the plants. We're finding no difference there either. So from what we can tell so far, even after 20 years of these treatments, there appears to be no negative effects in terms of soil properties in grazing cows. Okay, I think they've talked about some of the publications. So there's several different publications that are out there to help anybody who, if you have any questions about grazing or baling. They're easily found on UNL's website. And there's a lot of really good helpful information. So with that, any questions that you guys have?